this. I'm recording. Okay. Yeah, I am there. Okay. So let's talk a minute about the theory behind what a loop is. And really, a loop is pretty simple. It's just a command or a sequence of commands. It doesn't have to just be one command that's going to keep going and repeating until something happens, until some condition is reached, or until a certain number of iterations happen, or something else like that. Pretty straightforward. And so I can say something like, multiply 2 by 2, and it'll just keep doing it until I tell it to stop, even though that's a useless thing to have something do. But you know, you can do it. Now there's several different kinds of loops, and they really differ in how we make them stop. And so what 3 of these that are implemented in R that we're going to talk about today is, first off, we have a while loop. And a while loop happens while some condition is true. So as long as some condition that you set forth is true, it will continue happening. Like for instance, you can say, while the time is before 8 a.m. in the morning, continue to do this. That's something that you can tell it to do. We probably won't talk specifically about that. Or you can say, while some thing, like for instance, maybe I want to keep doing something until I'm collecting residuals. And I want to do that as long as all the residuals sum to less than 10,000. I can just run it until they reach that point and then shut it down or something like that. So, while is a loop that continues as long as some condition is true. A repeat loop is kind of the opposite. It repeats until some condition is true. So it'll repeat until something becomes true, and then it will stop. Those two we're not really going to talk about in here very much. The one that we're going to talk about is, earlier than that, what's called a for loop. And it's going to continue through a set sequence of numbers. So this essentially has a certain number of iterations it's going to go through. It's not going to do any checks or anything other than just to say, oh, have we gone through this sequence yet? And if not, we're going to keep going until we go through that sequence. And hopefully this will make more sense if it doesn't quite make sense at this moment. Can I give you diagrammatically how this works? So for a for loop, you initialize it, and it goes through and it sees, okay, is this iteration part of the sequence, or is our number part of the sequence? And if it is, it goes on, it does the command, and then it keeps looping until we've exhausted through the entire sequence. So whatever iteration we're on is no longer element of that sequence, and then it goes false and it ends. Pretty straightforward. A while loop, you initialize it, it checks some condition. If that condition is true, it will go ahead and run through its commands and then loop back and then keep doing that. If the condition is false, and then it goes ahead and terminates. A repeat loop, we check the condition at the end. So we'll initialize it, it'll run through some commands, and then it'll check the condition. If that condition is now true, it will stop. And if the condition is false, then it'll loop back around. So those are the 3 major kinds of loops. And again, today we're only really going to talk about this one, the for loop, which actually ends up being the simplest of those. Are there any questions on that so far? Okay, so let's talk about the basic syntax of a loop in R. The basic syntax, you're going to, okay, first off, everything here in red is going to be something that you will replace with something. But essentially everything else, and everything in white is going to be what actually stays. So for a loop in R, you'll put for, and then parentheses, some letter, like you generally start with I or J. That tends to be the default, but you can put anything. You can put BB. I don't know why you would, but you could. And then you set some sequence. Now again, a sequence can be given in any way that you really want to give a sequence. This could be like, you could use a C here. I can say 3, 6, 2, 5, that's my sequence. Or we could go 3 through 100, that's another way to set a sequence. Or I could do the SEQ, and I could do something like, okay, I want to go from equals 0 to equals 1 billion. And then I could do my length dot out equals 10. We do something like that. So any way that you want to set a sequence of numbers is permissible here. You just need to do something to set some sequence of numbers here. And then we close those parentheses. After that, we open up these little curly parentheses, the brackets, I don't know what you call them. And what you do is you put a series of commands in here. Okay. So once we do this, all this will do is it will run through and it will run this command. So if we have this sequence, there are 4 elements in that sequence, it will run 4 times. So it'll go 1, 2, 3, 4. If we take this letter, so whatever letter we gave here, so imagine we put an I, and we insert that into the command here, every time we repeat, we are going to replace that letter with the iteration of the sequence that we're on. Okay, so let's just imagine for a second. The command I put in there is I squared. That's all I do. And so if I ran this sequence, this C 3, 6, 2, 5, it will return to me, first it will return to me 9, and then it will return to me 36, and then it'll return to me 4, and then it will return to me 25, and then it'll terminate. It just runs through it 4 times. Every time it's putting 3 in here, runs the command, starts over, puts 6 in there, runs the command, starts over, puts 2 in there, so and so like that. So let's look at this real fast. Oh wait, where is my R? Give me my R. Put that over onto the other screen. Okay. So, actually I have one right here. So, if I put down in here, actually let me make this bigger. Bigger, please. Bigger, bigger, bigger. View, zoom in, view, zoom in. Yes, it's okay. You can zoom. Oh, bad. View, zoom in. View, zoom in. It's okay, really. Zoom. Everything in our world is big now. Ish. Big-ish. Oh! I'll do this differently. I can. Okay, so imagine that we run print, and I do 23, okay? All that does is it prints 23. One thing just to know is if you run the loop, it's not actually going to print output unless you tell it to print output. It's just going to do its commands. So if you tell it to take a mean of a bunch of things, it'll take the mean of them, and then they just go off, those means go off into the ether, and they don't really do anything. So you can't trust that that is actually going to, like, do anything. So imagine I do this. I do 4, and then in parentheses, I in 1 to 20, close parentheses, and then I put in print, and parentheses I. So it'll just print I 1, print I 2. So this will just return 1, 2, 3, 4, 5, 6, 7, 8. So if I run this, you look, that's exactly what happened. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 20. It ran through and just ran this command 20 times, putting each time for whatever it prints is going to put the iteration that's on. Or whatever in the sequence. If I change that to, like, for instance, that sequence to C, say 3, 5, 6, 1, 2, or that's 3, 0, 6, whatever. Actually, I'm going to change that to a 5. I don't care. Run that again. It just gives me that. So you can put in whatever sequence you want. Okay. Okay. Back to this. So that's the basics of a loop. So let's look at a couple of examples of this. So this is more complicated, and this is more how when I write a loop. This is going to be more how I do this. I'm going to put in my 4 initialization of the command here, so 4, and then I equal 20 to 40. Okay. And then put in my little curly bracket deep thingies. Does anyone know the actual name of those? Okay, what's that?
I've always just heard them called curly braces.
Curly braces? Okay, they're curly braces. Okay, and then I will, if I'm going to have a list of commands, I go ahead and just put them each on their own line, and then end with my little curly brace down at the bottom. Okay, so first off, have I told you guys about the rnorm command yet? Ooh, it's kind of fun. Let's watch this. So, let's make this easier to see. Okay, so this is a little bit easier to see. I go view plus view in. Oh, wait. View plus view in. Okay, so here we go. So if I do something like rnorm 10 comma mean equals 50 SD equals 4. Does anyone have any guess what that might do?
It'll give you a range of 10 numbers with a mean of 50 and standard deviation of 4.
Exactly. It'll give me random numbers that are sampled from a normal distribution that have a mean of 50 and a standard deviation of 4. So we run this. Here we go. We are given 10 numbers like that. Very good. Okay. So if we go back to what we have up here, I'm going to make x rnorm. I'm going to get 10 numbers, mean of I, so mean of whatever we put in there, and standard deviation of 7. And then for y, I'm going to take the mean of x, z, standard deviation of x, and then I'm going to print y and print z. So let's look at that. Actually, do I have that in here already somewhere? I should. Hey, look at that. Right there it is. So instead of putting in the whole thing, if we run that, so what we got now is a bunch of numbers that is a mean, standard deviation, mean, standard deviation, mean, standard deviation, mean, standard deviation. Yes?
So it automatically increments, so you don't have to set I equal to 0, be like the I plus plus. So you don't move forward.
Yeah, well, the only thing you need to do is the initial 4 part. Let me go back to, I need to go back over here. So as long as you do the initial 4 portion here, it will automatically increment. Yes?
What if you wanted to increment in steps
More than one? You just have a sequence that does more than one. So for instance, let me go back to this one. If I were to do something in the neighborhood of like, go back, actually let me just go back to this. Let's imagine we wanted to go from 2 to 40, but we wanted to go in increments of 2. I would do this. Sequence from equals 22 equals 40 by equals 2. So with the sequence command, you can either give it a length out, which gives it its total length, or you can do by, which says you go by 2s. So now if I just run just the sequence part of this, it gives you 2, 22, 24, 26, 28, on down like that. And so now we can run that by 2s. And there we go. If we pull back up that console again, we have those means. And they are kind of increasing. But they're random, so they actually don't line up. So like, I told it first to give me like a random or a standard deviation or a mean of 20, and actual mean was 14.3. I had a big standard deviation on there. Okay. Another thing that you can do that's kind of a nice practice is that you can do this and then not have it print out anything. Like imagine I don't want to print anything. I just want to like store those answers somewhere. So imagine I want not to just print out those means. I want to store those means into a vector somewhere. We can set up that vector beforehand, So for instance, we can do r mean equals 1 and standard deviation equals, or RSD equals 1. This just makes an object that we can put things into now, so it's not anything super special. And then do a loop something like this, where we have our standard loop beginning, again, 2 from 40. I'm doing essentially the same thing I did before. I'm just making all these means, these random number sets taking their mean. But now what I'm going to do is, instead of having it to print the mean of x, I'm going to give it that the object that I made up here, so r mean, and I'm then going to put into brackets something that will tell it to fill 1, to fill 2, to fill 3, to fill each element in there. So what I'm going to do in this case is then I'm going to do I, so it'll be 20, starting out with 20, then to 21 to 22. If I do I minus 19, for the first one, it will give me back 1. For the second one, it'll give me 2. This works easiest. You don't have to keep track of things if you just give it its sequence of 1 to whatever you want to do. Like if I want to do, this is probably the backwards way to do it. If I was actually running this, I would probably do this 1 to 20 or 1 to 21 and put my, if I really want my mean to come out 20 to 4, I'd probably do mean plus 19 rather than this minus 19 because it's a little bit quirky this way. But nevertheless, as long as you get this to be 1, 2, 3, 4. Another thing to notice is when I start r mean here and equal it to 1, it's just going to make that a vector of 1. It just has this one value in there. However, if I give it that and then I say, well, but r mean number 2 should equal this, or the second element, it will actually extend that vector every time and put what you want into there. So just by telling r that r mean bracket 2 should exist, it will make it exist for you. Is there any questions on that? Okay. So actually, let me go ahead and copy this code. Actually, no, do I have that in there already? Yeah, here we go. So I take r mean equals 1, RSD, so now what we have over here, as you can see there here in my environment, I have r mean was just this nice one, 1, RSD is 1. And I want you to notice what happens down here in the console when I actually plug this in. Let's plug in that loop. And run that. You notice that it just runs through the loop and then it ends. It doesn't give you any output in the console. You don't really know what happened. And since you don't know what happened, the only way that you actually know what happened is to go up here and look at r mean and look at RSD. So if we do that, actually I did this a little bit differently. I did 1 to 20. I just put I in here rather than 20 to 40 and I minus 19. But then if we look at the r mean, it gives us out our means. And if we read out RSD, it gives us out our standard deviation, so we can store stuff away. So that is one very useful way to run, well, hey, Ray Andrell, thank you. That was my office mate from my PhD, my first year of my PhD, he was my office mate. He actually came from Whitman. That's kind of interesting. Anyways. But yeah, again, be careful of your vector dimensions, because if you just put I in here, it'd start filling at 20, which means it would also actually fill in like 1 to 20 with just a bunch of NAs, and then you would start getting all of your numbers. It's not the end of the world, but it's a little bit of a pain. Also be careful of time, as some things can get crazy long and start taking lots of time in loops. This happens. And I was gonna run this code, actually maybe I will. So systime is this really nice little thing. If you do systime, it just like actually reads out the time at that moment that you run it. So what you can do is you can do start equals systime. So we save the time into this object start. And then later, we can take the systime again and subtract it from this. So essentially, we're just seeing the time that it took from this command to this command. So yeah, let's run this actually. I think I have that in here as well. Yeah, I got it right here. Would it be helpful for all y'all for me to send this R script to you so you can run it? Okay, I will do that. Probably not right after class because again, things, kids, and woo, rah rah. So I'm gonna just make this vector time. I am going to take the time. Then what I'm gonna do is I'm gonna produce our norm. Except I'm gonna go 1 through 7, and every time the number of R value or the random numbers I take is going to be 10 to the I. Okay, so these are the kind of things you need to be careful of because things in loop can get crazy big really fast. And I found yesterday as I was setting up this class that 1 to 7 works okay and everything lives and no one's killed. If I do 1 to 8, my computer crashes because it makes 100 million random values and tries to take their mean. Like 10 million, hey, we got this. 100 million, a bridge too far, and my poor little computer decides that it's dead. So let's go ahead and run this real fast. And it's actually going to run for a while. And one thing that you should have noticed here is this little stop icon came up right here. So let me actually run that again. And watch. Stop icon. Okay, and it goes away. As long as the loop is running, it'll do that stop icon. Let's go ahead and just run, like plot this. So I'm going to plot, actually I'm going to remove X first. Actually, I'm going to remove, yeah. I'm going to just plot on the X 1 through 7, and I'm going to plot on the Y the time. Figure margins are too large. Okay, let's do this again. I'm sorry, I messed everything up. Here we go, and let's zoom. So this is the individual time in seconds that it took for every iteration of that. So for 10 random numbers, no problem. 2 random numbers, no problem. 3 random numbers, no problem. 4 or 10 to the 4th. So 10, no problem. 100, no problem. 1,000, no problem. 10,000, no problem. 100,000. It's taking like noticeable time now. For 1 million, okay, it's taking like 1/10 of a second to actually run 10 million numbers and get their mean. And then we go to, wait, no, 1 million, it's taking time. For 10 million, it actually took 1.5 seconds. If, hypothetically, this would increase, but here's the thing, is it actually doesn't increase exponentially, it actually increases more than that because not only do you take the mean, but you have to store that number on your computer, all those numbers. And I actually found out that just the vector for the stupid, really big 10 to the 8 one that I did was like 750 megabytes just for that one vector. Oops. And then that takes resources to store that vector and do this. And so actually your computation time increases by more than to the 10th power. So things get like crazy long, crazy fast, and yeah. So you just gotta be careful of loops when you're doing it, that you don't do something that makes crazy big numbers on accident, or you'll crash everything and everything dies in your computer. Not like really dies. That'd be sad. Okay. So be careful of the time that's gonna take you to do all this. Let me give you one last example because this is cool. This might kind of tip my hand to where this will go eventually. Here's like another just useful thing for a loop. So for instance, we make this dice equals 1, and then there's a sample function, and essentially all the sample function does is take sample. Your first argument is going to be some sort of sequence or some sort of vector. And what it will do is it will sample numbers randomly from that vector, and then after that you give it the number that you want. So like for instance, I want to just take 2 numbers randomly sampled from this sequence. If you don't put anything in here, just this sample and then a sequence, it will just sample that sequence without replacement. So essentially what it'll do is it'll randomize that sequence, and it gives you for whatever you put in, it'll give you that number back. So like if, for instance, I did sample 1 through 6, just that, this will give me the numbers 1 through 6, but they will be randomized. If I do sample 1 through 6, comma 1, it will give me randomly one number between 1 and 6, one integer between 1 and 6. So what I have here is I have sample 1 through 6, 1, plus sample 1 through 6, 1. This is essentially simulating a dice roll. So you roll one dice, you're going to get some number between 1 and 6. You roll the second dice, you're going to get some number between 1 and 6, and generally you add them together to get your total roll. And so I'm just making dice equals 1, and then I'm filling it in here. So essentially what this does, I have 1 through 400. So this is essentially simulating 400 dice rolls, and then saving their results to this vector called dice1, or dice, not dice1. So if we run that, woo, and if we read that out, just dice, here's a bunch of numbers. That is what these dice rolled. 400 times. 6, 8, 10, 7, 7, 11, 6, 7. Wow, the low numbers are not doing very well so far. 9, 10, 5. There we got some below 6. 4, 3. Some games you'd be doing very poorly if you needed those low numbers early. And we can use the histogram function to kind of see what, never mind how they came out, but we won't do that. Okay. So, are there any questions up to that point? Okay, I'm going to finish this up with this. How do loops stop? So the thing I've talked about already is that there's different ways in which different loops stop. And so those conditions is like the primary way you want a loop to stop. You hope that it actually stops when it reaches the end of its sequence, or when the conditions are met, and everyone's happy and your loop worked the way it's supposed to. Less than half of my loops ever work the first time. Like, I screw them up and something goes wrong. So there's several different ways in which loops will stop. Number one, if any of those functions inside your loop returns an error, it will stop the loop and read you out the error. And so it won't go on. So you need to watch for that. If anything is going to return an error, it'll stop. Now, however, that being said, it can throw you warnings, and if it gives you a warning, it won't stop. Like, for instance, if one of the values it gets back is like infinite, it will just put infinite INF in there, and it won't stop. It'll just tell you when it's done. By the way, there's some warnings, and then you can look at the warnings. No big deal there. The other thing is if you have a loop that's going too long, like this happens all the time. Oftentimes your computing time increases more than just linearly or exponentially like you think. And all of a sudden, like, hey, this took 10 minutes to run with something. Now if I just, I got an hour I can leave this, or 2 hours I can leave my computer. I'll just run it with 10 times the number of loops, and I'll come back in a couple hours, 10 times, so it's 10 minutes times 10, that'll be 100 minutes, so that'll be just under 2 hours, I'm good. And then you run it, and like 2 days later it's still running. These kind of things have happened to me before. That's not good. And so you need to stop the loop. There's a couple ways you can do that. Number one, you can go into the console and just hit Control-C. That will terminate any functions in progress, including the loop that you're doing, so you can do that. Number two, that little stop button that popped up there in the upper right-hand corner of the console window, you can also hit that and it should stop it as well. However, that seems to be less reliable than Control-C because, like, I don't know, if the loop is really processor intensive, all of a sudden, like, that becomes less responsive for some reason. So Control-C seems to work better. So that is how loops stop. You can stop them, they can stop themselves, or that they can stop with the pre-agreed time, which is what you all want. Okay, so I'm gonna wrap up there. I did go really fast through this today, but I did record it as well. I'm gonna throw that up on D2L as soon as I can get back to my desk and actually throw that up there. There is a new assessment up on loops. It is short, it is essentially only one question. One question on the applied side. It's just write one loop. And it's a specific kind of loop. And there's data that is associated with it. But it's also going to tie into next next lecture. So we'll be back here on Wednesday. Thank you for bearing with me. If you have any questions, let me know. But other than that, I will see you later.